Hi, I'm at Wakin Bakin, the best breakfast in New Orleans that you probably never heard about. They are having problems with their biscuits and them either burning or undercooking. So they have asked me to come in and, using a fishbone diagram, figure out the sources of this problem. A fishbone diagram is a diagram that shows the processes of creating a project and different aspects that contribute to a product that could cause defects. The first thing we look at is measurements. This is asking, is the product in spec or is it out of spec? And what tools do we use to measure if it's in spec or not? The second thing we look at is materials. Are the materials the correct quality or is it not the correct quality? Could bad materials be causing our defects? Personnel. Do we have skilled personnel that can create quality product or need additional training? Environment. Is the environment that we are making our product in the best humidity, best temperature, etc. and so on, that creates the perfect product? Methods. How do we create the product? Is there additions or subtractions to how we create the product that would make it more efficient and better quality? And finally, what machines are we using to create the product and how could they contribute to defects? So the question is what is the defect for Wakin Bakin? Well, the defect for Wakin Bakin is burnt biscuits. And this is what happens when they find one.
That biscuit's burnt. Give me another biscuit.
What do you mean that biscuit's burnt?
Oh, look at that side. It's burnt. Black
Why is that
burnt.
biscuit burnt? This
Black
biscuit's
is burnt. Perfect biscuit.
No!
So now all I gotta do is get with their baker and go through the process and detail out what possibly could be causing this defect. So that means I need to get with Chris Scotland, who's their baker. And so I will add to the personnel file the name Chris, because that is who the baker's name is.
As you can see, these are not convection ovens, so there's no air current to equalize the temperature. So on the right side here, we're getting about 370 is what we're getting there. And on the left side, we're reading about 395. That's a pretty significant difference for something that's heat activated. Here's another environmental variable. We don't have a proofer, so we can't maintain a consistent temperature or humidity. So when I start, I check the thermostat and I just compensate for what it is for what it ought to be. What we'd like ideally is 80 degrees to 85 and pretty humid. What we have today is 75 and dry. So we'll have to make up for that as we go. Alright, when measuring flour, you don't want to scoop it and dredge it. You'll compact it and you'll get an inconsistent quantity. It's best to sort of shovel it into your container, level it off, and sift.
And how much is that container?
This is a 1 quart container.
Okay.
3 dozen biscuits, 2 of these. Just always do it the same way every time. And no matter what they tell you, always sift it. Okay, important note, since we're making small batches, we're working by volume. Ideally we'd like to do large batches and do it by metric weight. It's just more consistent and precise. But small quantities don't come out as consistently if we work by weight, so we are using good old-fashioned tablespoons. Salt. Sugar. Baking powder. And blend. We're going to cut in 1 pound of butter, and to do that we want it to be in in small cubes. And it's easiest to do this with the butter nice and cold, so I took it right out of the cooler. So it's right at 42 degrees. Otherwise it will tend to melt back together as soon as you're done cutting. Alright, cut it one way, the other. It's already kind of getting sticky because it's warmer in here than it normally is. Separate it. And this is called a pastry blender. It's really made just for cutting butter into flour, what it's for, pie crust, etc. I'm going to give it a couple passes with this, and then there's still a part that pretty much has to be done by hand. I have yet to see the machine that does it right. Okay, this next step pretty much has to be done by hand because they make machines with paddle bits that do it, but the problem with the machine is it does it too consistently. To get a drop biscuit to crumble properly, you actually want some deliberate inconsistency. And the best way to do that is to hand cut the flour a little bit until it looks like it's almost ready, and then stop right there. So you're looking to stop just short of what you think it should be. Otherwise you go too far. And just like a muffin that's been over blended, it won't get that nice little crumble to it. You can really just keep doing this until the flour starts to turn a little yellow and you can smell the butter. Because really the heat in your hands is kind of doing a lot of work here. Develop a special muscle right there. I think that's called the biscuits. Grind that together a bit. An eye out for large chunks. Alright. It looks yellowish in tinge. Yep, it's smelling like butter. Now the real test is it should just cling together in your hands, just like that, and fall apart if you squeeze. So this is well blended right there. Now I'm going to stop before I overblend it and add my liquid ingredients. Okay, liquid ingredients for a single batch. We want 3 cups of cold milk.
And that's exactly 3 cups?
Right there, yes. You have to kind of tilt your head a little bit because the lighting in here is bad. This is a locally produced honey. We use it because it tastes fantastic, but depending on what season it was made in, you get a little variation in the consistency. So if it ends up too watery, we'll have to kind of add a little flour back to compensate, and that's just done entirely by eye. Fortunately, Archimedes' principle still works. So if you stick a straw in there, the air can bypass it and it won't just go glunk, glunk, glunk. And 1 cup. I hate to waste a drop of this if I can avoid it. And the honey together really well. Use a strong spoon. Make sure you don't have any pockets of flour lurking in there. And if you take a look close up, you'll see it's got that specific inconsistency to it. You can see little chunks, you can see some slightly larger chunks, and that's exactly what we want. So, looks like the honey we've got today is just about right. I don't have to adjust that any, but now, since I've been working with it, it's warmed up a bit, I suspect, and it's going to be too liquid. Yeah, it's just over 60 degrees. We want it a little between 40 and 50. But we have ways of fixing that. And we'll check the temperature on that in about 20 to 30 minutes and start something else.
Okay, so with this first part of making biscuits, what did we learn? We learned that as far as machines go, that the ovens have uneven temps. We learned that in the environment they can't maintain a constant temperature and they can't maintain the humidity. We learned what the materials for making the biscuits were. We learned what was used to measure and what the measurements were. And we learned what type of methods were being used in the process of making these biscuits. Let's see what the next steps are.
Okay, it's been about 30 minutes. Let's see if our biscuit dough is down to, this is an instant-read thermometer, which is a bad name. It's not that instant, but it's close. And it's a lot easier to read. We're looking for anything under 60 degrees. And it looks like we're 57.5, which is about perfect. Too cold, and it's hard to scoop. Too warm, that's a bit. That's called the cut. You want a really sharp edge along the bottom there. Small air pockets are okay. And that'll start your layout. Okay, here we have a full sheet, 35, 5 by 7. spaced as equally as you can make them. Spacing is very important because they actually encourage each other to rise, and you end up with a little extra space on the ends. So these are sitting right about like they're supposed to. It's worth mentioning I'm doing this in here because the airflow from the vent hood would suck all the moisture out of them if I did the scooping in here. Alright, this is going to have 2 cycles of with one rotation in between.
And why do you do rotations?
Because this is not a convection oven, so there's no internal airflow to equalize the temperature. 7 minutes, turn, 6 minutes. See you in 7 minutes. Okay, I'm going to give them their first rotation. I'm going to open it up and go right about 3 seconds. And we see just a little bit of browning on the top. They've spread out a bit. And the next time we see them, they should have kind of made it more dome-shaped. And we'll see you in 6 minutes. 2 seconds. Alright, and let's see what we got. Okay. We got a nice rise on them. A little bit of browning on top. If any of them have burned, it'll be this one right here. And it looks like 5 more seconds and that will be burned. We're good, nice and brown, right on the edge. Let's take a look at this one. Oh dear. Yeah, see? I can't sell that. But that one's perfectly fine. Can't sell that one. Can't sell that one. Can't sell that one. So 1, 2, 3, 4 out of just shy of 3 dozen. Yeah, fine. 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 Fine.
Sometimes
nice. Well, I mean, it's nice and crumbly. Bear in mind that the insides are still baking, and they'll continue to bake for another 15 minutes.
Okay.
Yeah, that one's fine. So, out of 3 dozen, we lost 4, which is too many, really. But I mean, you can see, looking at the tops, it goes from least done to most done, and kind of this way. And most nights it's actually this side, but tonight the left side is overheated. Probably because of what looks an awful lot like a residue of bacon grease stuck to the bottom of the oven deck. So that's influencing the temperature. So there you have it. So we pretty much lost 4 out of 35. That's just too many, right? Now on the next batch, I can maybe take, because this is really close. This is maybe 5, maybe as many as 10 seconds over down here. Now I can take 10 seconds off the timing, but then I have to watch to make sure these aren't underdone, which, to be honest with you, I think the next batch, if I take 10 seconds off, I won't lose those 4. So that means I lose 4 out of 70, and so on and so on, etc. So basically, the first batch of the night gets to help me calibrate the timing for the rest of the night, and tomorrow it will be slightly different.
And that's the problem.
Yes, I have to check the oven temperature in several different places every night and try and find where tonight's hotspot is. So, I mean, these ovens are fully depreciated for a reason. They're not convection ovens, they're conventionals, and they behave irregularly. They're at least 10 years old, and it's past their prime. Okay. So, I mean, it's nothing we can't work with, but we always lose a little bit of product each night finding out what its particular temperamental thing is tonight. So yes, I can confidently say that that's probably as good as the problem.
Okay.
How's that?
So what did we learn from this second part of the process? We first learned that there were more instruments and measurements that we need to record. We learned that the environment that the blower can over dry the product if they leave it in that one room. And we learned that because the oven temps are uneven, they have to rotate as a method. The primary problem, therefore, that we can say causes the defect of burnt biscuits is that the oven temperature is uneven throughout the oven. And the best way to fix this, of course, would be either to fix the oven, or in this case, where the oven is as old as it is, to replace the oven. Unfortunately, being a small business and being just in the first couple years of starting this business, the owner may not have the money to replace these ovens. And therefore, they're going to have to keep using the rotating process. The secondary thing we learn is that the environment is not conducive to making biscuits. Because of this, it would probably benefit them to move locations. Once again, being that this is a first couple years of a business starting up, the owner may not have the funds to go to a new location that's more conducive to this type of baking. So this is how you use a fishbone diagram to figure out what causes defects in the process. So I hope that seeing things be made has gotten you hungry, but if not, maybe this will get you hungry. Or this. Or this. I want to thank my friends at Wakin Bakin for letting me videotape this process and go through this process of getting a fishbone diagram built for them over a problem that they have been having. They would like it if in return you would come out to Wakin Bakin and have something to eat. As I said, it is the best breakfast in New Orleans you've never heard of. And with that, good night.